Today I will be doing a small experiment on does the three states of matter, solid, liquid and gas, occupy space. I will start the experiment on solid first. I prepared a container with water. As for the solid, I use rocks and a marker pen. First, we make a mark on the water level. And we put the rocks inside the water. As you can see, the water level rose up, so that means solid do occupy space. Next, I will do the experiment on liquids. Same, I prepared a container with water and a marker pen. And for the liquid, I use shower gel. Same step, we mark the water level. And we pour the shower gel inside the water. Same result. The water level rose a little bit, so liquid does occupy space. As experiment, I will just need a balloon. Inside the balloon has air, and air is a type of gas. We cannot use our eyes to see gas, but this experiment proved that gas has mass, and that means gas can occupy space.
Hello everyone, I'm Tsin from Junior 3 Cell. Today, I would like to share with you about the composition of human digestive system. When food enters the mouth, it will go through a food passage called pharynx. After that, it will reach the esophagus. In here, food will be pushed into the stomach by means of peristalsis movement. Next, it will reach the stomach. In here, stomach will store the food temporarily and performing preliminary digestion of proteins. The stomach wall possesses smooth muscles which aid to green and churn food. Then, the food will continue to move toward the small intestine, which is the main cell of digestion and the absorption of the nutritive matter. Lastly, the residue will go into the large intestine and form faces, hence be adjusted out of the body through the anus. Above is the digestive tract of the human body. While liver, gallbladder and pancreas is a digestive gland, liver secretes bile that break down fat into oil droplets, while gallbladder store bile. Meanwhile, pancreas secretes pancreatic juice, which include enzymes that help breaking down the nutritive matter. That brings us to the end, and that's all for today. I'd like to thank you for your time and attention.
My name is Angelica Chinsiyi and I'm from class Junior 3E. My class number is number 8 and I will be building a blood flow model. This is the table of contents for my presentation. Before we start, let me introduce you to our circulatory system. Eating healthily and exercising keeps our blood flowing well through our circulatory system. Our circulatory system transports blood through our heart, veins and arteries to provide oxygen and nutrients to our body. If this blood flow doesn't work properly, it can negatively impact our health. The most common problem with the circulatory system today is coronary heart disease. It is caused by plaque buildup in the wall of the arteries which supply blood to the heart. This process is called atherosclerosis. As the arteries narrow, they cannot carry as much blood to the organs. The decrease in oxygenated blood can lead to many health problems. The symptoms of coronary heart disease includes chest pains, shortness of breath, lightheadedness, and nausea. The materials used for the activity are 2 disposable plastic cups, 1 wide and narrow straw, modeling clay, a stopwatch, a tray or shallow tub, red food coloring, a measuring cup, a pair of scissors, and a piece of paper to record the results. These are the preparations for the activity. These are the procedure of the activity. This is the blood flow model for the white straw. This is the blood flow model for the narrow straw. As you can see from the video, the time taken for the water to stop flowing in the white straw is 8.16 seconds, whereas the time taken for the narrow straw is 25.83 seconds. The conclusion of the activity. Testing the setup with the white straw simulates a healthy cardiovascular system where the arteries are free from any plaque. The red water in the model is the blood which flows through the arteries. As we notice, the red water flowing out of the cup is relatively fast. Meanwhile, the second setup with the narrow straw represents an unhealthy cardiovascular system. With the narrow straw, the water takes a longer time to flow out of the cup. The artery straw is starting to get clogged with plaque, and thus the diameter of the artery gets smaller and smaller. This also means that less blood can flow through the artery. To reduce our risks of getting coronary heart disease, we should reach a healthy weight, be more physically active, and manage our stress well. However, we should not smoke, increase our alcohol intake, and eat an unhealthy diet. Though treatment of heart attacks has improved drastically in recent decades, coronary heart disease remains the leading cause of death worldwide. Therefore, it is important for everyone to exercise and eat healthily throughout life, which helps keep arteries open to good blood circulation. I have now come to an end of my presentation. Thank you.
大家好，我是郑景伦，来自初三合班，我的座号是3号。今天我要带来的实验是要证明 ammonium chloride 可以做成一个 cold pack。我们通常都会在我们发烧的时候敷上这个 cold pack， 因为它拥有降低温度的作用性。在这个实验里，我们采用了 endothermic process 的原理，因为物件它吸热过后，温度就会下降。首先，我们要准备的材料是一个空的纸袋，15克 ammonium chloride， 一个袋子装着一些温水，还有一个温度计。现在我们在温度计上面可以看到这个热水的温度，然后我们将刚刚的 ammonium chloride 倒进这个空的纸袋。现在我将剩有水的这个袋子放进去有 ammonium chloride 的袋子里。现在我把外面的纸袋修好，我把袋子摊平，让 ammonium chloride 和水在一起混合。过了1分钟后，我把温度计放进去刚刚的袋子里面，我们可以看得到这个温度计所记录的是34度。通过这个实验，我们可以证明到融化后的 ammonium chloride 是可以吸热的，因为我们可以观察刚刚在温度计里显示的温度是从40度在短短的1分钟内掉到去34度。谢谢。
In 1977, scientists exploring the Galapagos Reef along the mid-ocean ridge in eastern Pacific noticed a series of temperature spikes in their data. They wondered how deep ocean temperature could change so drastically from near freezing to 400 degrees Celsius in such a short distance. Scientists have made a fascinating discovery: deep-sea hydrothermal vents. Hello, I'm Amberly.
And I'm Wang Chongming.
We are from Senior 1 Xiao. This video will share some information about the hydrothermal vents, which had an ideal condition for origin of life.
Hydrothermal vents are like geysers or hot springs on the ocean floor.
They are one of the most spectacular features on the seafloor.
They form in places where there is volcanic activity such as along the mid-ocean reef.
Water seeps down through cracks in the seafloor and is heated by the molten rock deep below the ocean crust to as high as 400 degrees Celsius. Hot fluid rises through the rock and gushes out of the vents opening and surrounding seafloor. This hydrothermal fluid carries with it dissolved metals and other chemicals from deep beneath the ocean floor.
Hydrothermal vent structures are characterized by different physical and chemical factors, including the minerals, temperature, and flow levels of the fumes. Black smokers emit the hottest, darkest fumes, which are high in sulfur content and form chimneys up to 18 stories tall, or 55 meters. At approximately 400 degrees Celsius, the vent fluid of black smokers is hot enough to melt solid metals such as lead. The fumes of white smokers are lightly colored and rich in barium, calcium, and silicon. Compared to black smokers, white smokers usually emit cooler fumes and form smaller chimneys, and it is around 250 to 300 degrees Celsius. Vents with even cooler, weaker flows are often called sips or diffuse flow. They appear to shimmer because of the differences in water temperatures, or bubble because of the presence of gases like carbon dioxide.
Scientists also realized that an entire unique ecosystem, including hundreds of new species, existed around the vents, despite the extreme temperatures and pressure, toxic minerals, and lack of sunlight that characterized the deep-sea vent ecosystem. The species living there were thriving. Scientists later realized that bacteria were converting the toxic van minerals into usable form of energy through a process called chemosynthesis. Some bacteria live in or on tapeworms, clams, mussels, and shrimp, forming symbiotic relationship with these animals.
Vents can support a complex ecosystem of exotic organisms that develop unique biochemical adaptation to high temperature and environmental conditions that we would consider toxic.
The researchers also point out that the deep-sea hydrothermal vents are not unique to the Earth.
Space missions have found evidence that icy moons of Jupiter and Saturn might also have similarly alkaline hydrothermal vents in the sea.
Learning about this organism can teach us about the evolution of life on Earth and the possibility of life elsewhere in the solar system and the universe. We still don't know where life first formed. A study shows that we cannot rule out the possibility of deep-sea hydrothermal vents. That is all from us. Thanks for watching.
Today we are going to make an air pressure experiment. We need water, a transparent glass, a lighter, a candle, a napkin, and a tray. Pour water on the napkin. A little bit of water is enough. Light the candle on top of the napkin. Cover the candle and apply a little bit of pressure on the glass. Then lift the glass up. Now let's put pressure on the tray a little bit of weight. Now let's try to lift it up. Why this happen? When put the glass over a burning candle, fire use all the oxygen available in the glass. After using all the oxygen, the fire extinguish. Hot air cool down and start contracting and try to pull wet napkin, which create a suction. The glass gets stuck with the tray. The outside air pressure is more and there is a vacuum in the glass, so the glass can lift the tray. The force is so strong that even put weight on the tray, the glass able to lift it up. Thank you.
Hey guys, my name is Ryan. And I'm Ian. So today we're doing a project called the Paper Experiment. Okay, so the reason why we did this project is to find out what makes a paper plane fly the longest time and the longest distance. Okay, so we have 4 planes right here. They are labeled A, B, C, and E. And we came up with a hypothesis that plane B will fly the longest and plane A will fly the furthest. Okay, so we'll be doing 5 attempts on all of the planes, then we'll report the distance and time flown. And then we'll take the average of each of the results, then compare with each of the planes. So, right, let's start. Okay, so we'll be starting with plane A, and this will be our starting point. Alright, so now we'll be doing plane B. Plane C. Okay, plain D. Alright, so based on the results, you can see that plane A flies the furthest because it has a long and sharp structure, which gives it more thrust for it to fly further in the air.
And plane B here can fly the longest time because the larger surface area gives it the biggest lift to fly longer. Yeah, so our hypothesis was correct.
Thank you.
My name is Ashirun from class 02I.
Hello, my name is Jonathan Tshung. I'm from S2I.
And today, we are going to do the elephant toothpaste experiment.
Elephant's toothpaste is a foamy substance caused by the rapid decomposition of hydrogen peroxide using a catalyst such as potassium iodide or yeast. When hydrogen peroxide decomposes, it creates water and oxygen. The released oxygen is then mixed up in the soap to create a soapy bubbly mess. But did you know that using different concentrations of hydrogen peroxide can create different results? So, today we're going to test that out by using 6, 10, 20, 30 and 50% of hydrogen peroxide.
For each of the tests done, we use 100 milliliters of hydrogen peroxide, 10 milliliters of dish soap, some food coloring, mix it well, and finally 12 milliliters of 50% potassium iodide catalyst for the reaction. And this is the result. As you can see, different concentrations of hydrogen peroxide affect the reaction both in size of the foam and speed of the decomposition. In the 50% reaction, you can see steam is coming out of it. This is because the reaction is exothermic. It creates a lot of heat, up to 94 degrees Celsius.
So, thank you so much for watching. I hope you enjoyed it and learned something new.
Good morning, teacher. My name is Menta Fan from Senior 2 Ping. Today we are going to do an experiment. First of all, we need to ready a paper plate, paper cup, soap, hand sanitizer, a little water, and a little of pepper powder.
Hello, my name is Cassandra from Tshung.
Today I will be experimenting with sticky notes.
Have you ever heard that two phone books with the pages stacked together are impossible to pull apart? This might seem crazy, right?
In this experiment, I'm going to use sticky notes instead of phone books. How much weight can they support when you interleave the pages? Now I will show you. The materials are 10, 20, and 150 pages stacked sticky notes, paper clips, mini C-clamps, and a 5 kg dumbbell.
Now let's start with our experiment.
First, we are going to use a 10 pages stacked sticky note. 1, 2, 5, 6, 21, 31, 32.
And next is the 20 pages sticky note.
Lastly, it's the 150 pages stacked sticky note.
As you can see, it can hold more than 5 kg of weight. Now we have come to an end for the experiment. Let's recap the results. The first experiment could hold up to 32 paper clips. The second experiment could hold up to 383 grams of weight. And lastly, the final experiment could hold more than 5 kg.
So what holds the paper together?
The answer is friction. Even a small number of interleaved pages can result in a surprisingly large amount of friction, making the sticky notes impossible to pull apart.
How can the sticky notes support that much force?
To understand this, first you need to understand a little more about friction. The friction force between two surfaces depend on two factors: the normal force, or the force acting perpendicular to the surfaces pushing them together, and the coefficient of friction, a constant that describes the friction between two materials. For example, your shoes and a carpeted floor have a higher coefficient of friction than your shoes on ice.
So, the higher the coefficient of friction, or the higher the normal force, the higher the resulting friction force. What then results in such a high friction force between the interleaved pages of the sticky notes? The coefficient of friction does not change because the materials stay the same, so it must be a high normal force.
What exactly causes a high normal force? When you try to pull the sticky notes apart, the interleaved pages are squeezed inward. This increases the normal force on the pages. Conceptually, this works just like a Chinese finger trap. The harder you pull, the harder the pages squeeze together.
That's it for the video. I hope you can try this experiment at home.
祝沙巴崇正中学56周年快乐！
祝沙巴崇正中学56周年快乐！
庆祝沙巴崇正中学56周年校庆！
我是张金彩，大部分人都叫我 Mrs. Lee， 崇正的化学老师。我是在1975年沙巴崇正中学改革时进入崇正服务，一直到2006年退休。所以我常说，你们在崇正3年、6年或者8年都可以这么爱护母校，而我在崇正服务了31年，比起你们，我更爱崇正，更加算是崇正人了。我刚进崇正的时候，只有9个老师，除了教高中化学及数学外，还要兼教初中的科学和数学，每天要准备许多不同的课程。一直到1987年后，学生逐年增加，高中理科班学生稳定下来后，我才教自己的专业化学。虽然我退休了15年，可是每次听到别人议论崇正时，我都会很认真、很细心的听。这几年我听到的评语，很多时候都是好的，比如某人在工作领域中有较好的成就，大部分人都认为他是崇正毕业的吗？而确实很多时候他正是崇正人，我亦有容颜。当然也有不好的时候，如社会人士或在校或理智老师说现在的学生很难搞，我的想法又不一样。什么时代都有坏学生， 崇正这个大家庭已经是做得很好的一群了。我看着崇正的成长是从零开始。1965年，崇正借用比中的校舍上课，那时我是比中的学生。到我念完大学回来服务的第1年，崇正仅有1栋校舍，还包括了办公室、教师宿舍等等，学生只有200多人。然后建筑物一栋一栋的增加，一直发展到今天一个宏伟的大型中学，学生有2000多人，这是多么的不容易啊！千年树木，百年树人。今天崇正的成就是前面的崇正人给学校打好的基础，后面的人顺理成章地进入一间好学校。现在的崇正人才可昂首挺胸地在人前。今年是崇正56周年的校庆，我有幸在此也祝贺崇正中学校誉蒸蒸日上，享誉全球。
崇正56周年快乐！
我是87崇正人邓恒辉，现居澳洲，是一名妇产科医生。母校的3语教育为我的学业跟事业奠定了稳固的基础，恩重如山，无以为报。当年的老师跟同学依然是我最知心的一班朋友。现任的正副校长和数位在职的老师也是同年代的师兄弟姐妹，为学弟妹树立良好的榜样，我也常引以为傲。感谢校友会凝聚海外校友不遗余力，我们虽身居海外，但心系母校，希望日后能继续参与母校的发展。在此祝贺母校56年校庆，桃李不言，夏至晨曦。谢谢。
我们
高山人吧
在这里
祝沙巴崇正中学
56周年
快乐！
祝沙巴崇正中学生日快乐
Happy birthday to Sabah Chongchen Secondary School.
Selamat Hari Jadi kepada Sekolah Menengah Chongchen Sabah.
恭祝沙巴崇正中學生日快樂！